Alright, time for the draftphysics.com video presentation. Debatephysics.com also. And we are looking for someone capable of talking about some of these issues. And certainly arguments, disagreements are more interesting than agreements. So, but they're more difficult to do without, offending each other or some other kind of crap. And that's unfortunate. But that's what I am seeking, somebody who can be disagreeable without being disagreeable, so to speak. Disagree without being disagreeable. Something like that. A little cough. Anyway, so this Preston Becker guy made a video response now to Veritasium's original video, basically saying something silly like inductance happens before the electricity gets to the light bulb. Yeah, everything's an inductor. Everything's collecting energy and reflecting it back to the universe. So that could be a statement in and of itself, independent of all other physics conversations. Could be the simple premise that every single thing, whether it likes it or not, is enjoying your cell phone conversation. I mean, every little piece of crap in the universe, so to speak, theoretically, with enough time, is going to experience every bit of the energy that's going to travel through its direction, its place in space. So anything that has energy heading that way, it's like the sun is illuminating the entire universe. Our sun is shooting photons to all the other crap in the universe, theoretically. Some little piece of the sun ends up there eventually. And that would be the more, that's getting to the truth of it, that any fields or forces, you want to call them that, are really already in the environment. And the question is how much of it are you reflecting? And, that would be a real elemental, in my opinion, getting on the right track in terms of understanding the truth, what really happens. So somewhere in the title he did have the real, how electricity really works or something. I think he changed that, and whatever. The original video was a little bit different. But it doesn't matter. It's a response to Veritasium's video, Big Misconceptions About Electricity. And then this video is sort of a counter argument, like, no, this is the real story. And I'd say this story is still lacking a lot of real elements. But anyway, let's get to it. This is going to take a while. More than one video, probably.
A few months ago, I was browsing through some of Veritasium's old videos when I found this. The big misconception about electricity.
So he's standing here, right, and he's basically making this argument that, look, I'm a meter away from the light bulb, and I have a battery here, and, does the energy have to go through the wire to light the light bulb? And yes, no, the subtle truth is that if any amount of energy at all is all you need, is when this wire, is energized, electricity is put in it. The fact is, it's going to now reflect the universe differently because its electrons are now moving. The movement of the electrons is basically essentially my hand moving towards you. Woo. And if it moves away from you, and as I can theoretically point out, if I could move my hand at the speed of light, right, I'm hitting you with a ton of energy going this way, because all the reflections will be collected until my hand gets to you. And if I go the other way, my hand becomes invisible, and you get no reflections. It's very quiet from this place in space, because I'm not going to reflect any energy. And I'm not going to transmit any through me either. So you're not going to see much light from that piece of space. And those on-off signals are how everything is communicated in the universe, essentially. It's just by doing this, on, off, and those signals being sent by positive and negatively charged objects are what create the capacity for things to action at a distance. And that's why it happens at the speed of light, because it's actually the speed of force, but whatever. So anyway, so clearly he's making this argument, the assertion that the wires are antennas. So what? This isn't new physics. There's no new argument here that, yes, initially when you turn the electricity on, the other wire is going to sympathetically mimic the wire you've turned on, and the other wire is going to feel the effects of that and mimic it and create a little tiny bit of electricity, but it's a little tiny bit, all right, and it's going to be over very quickly. And so, like I said, this was sold as if, no, this is proving the real, how the light bulb really works and how the wires really work. The antenna part is just a symptom. They're not trying to be transmitting lines, but they just happen to be. Everything that has electricity in it is transmitting to the rest of the universe that it has electricity in it to it, because it's changed its profile. But it's like the DC thing. Once it changes, everything else adapts to it. So unless it changes back, unless it oscillates, the rest of the universe accommodates the new condition, and that's the end of it. But anyway, continuing.
And of course, I didn't want to be harboring any misconceptions about electricity, so I hurriedly clicked on the video to update my understanding. And may I...
Yes, my impression of Veritasium video is just looking for the catch. He's always trying to do something edgy, and he's pushing it, and the rationale is, in my opinion, kind of rubbish, okay? It's like he never really properly explained the air car, okay, the wind car, in the sense that the whole thing just depends on you being able to change the pitch on your propeller blade. If I make a propeller that has straight, flat blades, it's a sail. It's not a propeller anymore. It doesn't matter how fast I spin it. If the sail blades are straight, it's not a propeller anymore. It's a flywheel. And so it can store energy by spinning, okay, but it's not going to make any wind. It's not going to, do anything except allow wind to hit it. So it's going to be a sail. And as soon as I start pitching it, okay, then I'm turning it into a fan. And that's the reason why you can take advantage in this subtle way. It's because you can change your flywheel into a fan. And so you can store a little bit of energy in the momentum of the flywheel, and then you can steal that energy by pitching the flywheel. So you didn't get that answer right. His answers are always a little bit, he's just playing semantics, word games, to pretend there's some new physics when there really isn't.
Say, my understanding was updated. You see, I used to think that energy flowed through the wires in a circuit, but it turns out that it actually flows around wires.
So energy is the key word here, and that's the part I'll want to get to, is that what's the nature of the real energy. So any of the field effects, I would argue, have nothing to do with the energy, because you know that the energy gets from one place in the wire to the other place. Okay, it goes from point A to point B, and if you make a good enough wire, it does so with 100% efficiency, the superconductor. And so any field effects are just symptoms. They're not made out of the energy in the wire. They're made out of a change in an environment that doesn't have anything to do with the wire. So again, I'm reflecting the universe constantly. Light's reflecting off of me. That's not my energy. I didn't provide the energy that you see me with, right? The photons you're seeing didn't come from me. I didn't give them to you. I didn't produce them and then you shot them at you. I'm just reflecting them. And that's the nature of these fields. So all these fields have nothing to do with the actual energy in the wire. That energy is not used to make a field. The field is a symptom of it doing it in an environment that's pressurized, that's full of energy. So it's separate energy that I'm affecting. I'm affecting a separate field of energy. I'm not making a field of energy. I'm changing a field of energy. Big concept, gigantic concept. You don't get that one, everything else is going to get messy and sloppy and wrong.
As shown by the pointing vector. And because of this fact, a light bulb placed right next to a switch will turn on almost instantaneously when the switch is closed, regardless of the length of wire that can...
So it will turn on as fast as, at the speed of light, you can move between the two wires. So the closer I put the wires, the faster it happens. And obviously, the closer they are, the more of this effect will be seen by the other wire. So obviously, if I put the wire far enough away, the effect is diminished by the r squared rule, or even the r cubed rule, which means it weakens at a preposterously unpleasant rate.
Next, the two components. And to think, I used to tutor people in this subject. I've never been so ashamed.
So the joke bits are okay, I guess, blah, blah, blah. So now he does the, wait a minute.
But wait a minute. Doesn't signal latency depend on cable length? And if energy
All right, signal latency. So there's obvious points where you can make a light bulb do something. Okay, it can sing and dance, so to speak. And the singing and dancing can't happen instantaneously because it's actually a process and it has to wait for get through the wire. So you can put the music into the wire, but the tune isn't going to be heard until it goes all the way through the wire. So if this was a song you were playing, you can't play the song. All you can do is have a funny little note happen, a sound that happens like the scritch on the record when you first put the needle down. It's not part of the music. The bang of the needle isn't part of the music. So yes, the inductance is an event that you can't prevent, but it doesn't have really anything to do with what the wire's actually going to accomplish.
flows through the middle of a circuit, does that mean you can alter the energy flow by adding objects to the middle of the circuit? And when the video ended without answering some of these questions, I realized I was going to have to find the answers myself.
Or watch other people who make videos of this style pointing out, what could be argued are games being played. Like the catch line of any current at all lights the light bulb, that kind of catch. So it doesn't matter whether it's a millionth of the current necessary to actually create light. It's just a catch saying, okay, we're going to count that as lighting the light bulb even though it didn't really do that.
Through the most authoritative sources that I could find, I slowly gathered various pieces of the puzzle. And when I've had the full answers in front of me, I came to the realization.
So this whole full answer thing is a little bit dicey. I'd argue there's lots of electric theory that is incomplete and really broken, frankly. I mean, the very idea, look, you're going to talk about some of it, that Franklin assigned plus and minus wrong, and essentially, that means that Maxwell's equations have the current going in the opposite direction of the voltage, and that's a huge mess. I mean, it's just wrong.
That Derek really didn't do a very good job explaining some of this stuff. So, for the 7 people out there who are still interested in this question and are looking for more insight,
well, there could be 7,000 people, but yeah, they're never going to find your video. So that's the real problem, the disconnected internet, where, yes, there's absolutely no way to organize content or find content, and certainly Google won't help you find it.
This is the video for you. Derek's main point is that energy does not flow through wires, but instead flows through electric and magnetic fields.
So it obviously flows through the pressure between, in my opinion, okay, something that could be stated as, oh, come on, it's a fact. So if you just thought of electrons as magnetic monopoles, just think of them as little north magnets. And so they hate all the other north magnets. And so in the wire, all that's really going to happen is you're going to take a sized vessel that has a certain atoms in it with a certain number of electrons, and you're just going to add another negative component, another north-facing magnet, and you're just going to increase the pressure between those magnets. So the more magnets I try to cram into a space, if you thought of them as north side little balls, the more I try to cram them in, the higher the pressure they're under, and the farther they'll shoot away if I could release them from their vessel. So the more I cram in, and I could just make the vessel disappear that's holding them, they'll fly away at a much higher and higher speed because I'm increasing the pressure. So the voltage is the pressure, the amperage is the number of elements that are being involved in the process. I would say the elements are the atoms. So the number of atoms that are having electrons participate is the amperage. So, and these are like key concepts in understanding that magnetism is an atomic function, and it requires you to involve an atom. You have to polarize the atom to create the magnetism, the polarization. And so yes, so if you want to use electricity to create magnetism, you don't need high voltage, you need high amperage. You need to involve lots of atoms in the process. But it's another key point. It's just that amperage is about the number, the amount of the material being used, okay, to convey the pressure, and the voltage is the pressure. The how close, what's the density of the electrons. So as you increase the density of the electrons, you increase their pressure and you increase their voltage.
Which raises the question, what is a field? To properly appreciate fields, we first...
So yeah, this is what gets force and field. So again, I've made these distinctions, lines of force and field. So maybe we'll start drawing a little here, because he's going to also draw similar things. So I might as well make my clarification now than later. Alright, so I've said this before, but I mean, the good thing about Maxwell is that charge is represented very well as lines of force. Okay, not field lines, but lines of force. And that the idea would be is that the positive and the negative thing, okay, are producing a different light. So if I just made it into light and just said, okay, these are red photons and these are blue photons, okay, so understand that they're both radiating a force. Because what the bad news that Maxwell does is that he takes objects that are the idea of radiating a force, lines of force, and then you measure how strong the field is by just counting how many lines you intersect. You intersect more lines per your size, I mean less lines, out here than you do in here. Okay, so the closer, I didn't draw that very well, but say this line misses you and this line misses you, only this one hits this object. Obviously this object gets hit by 3 lines. So the closer you get, the more lines you intersect, the more force that you're being affected by. So if you just thought it as sunlight, so it's blue light coming off electrons, red light coming off of protons. There's no idea that a line here goes into, okay, so they're both radiating light. They're not absorbing in this case. They're just reflecting, but I don't really want to have to do all that. And then your field lines, okay, the lines they draw radially around something, right? Those lines, the shape of those lines is just decided by how much pressure, how much blue and how much red there is. So it's basically just saying, where's the purple location? Like what places have the same pressure? If I was to draw all the places that have the same pressure going in, out, you know, where are those locations? And so these are not real lines. There's no real line here in space. It's just an arbitrary line defined by what you can calculate to be what the effect is going to be at a location. You know, how much blue you're going to see and how much red you're going to see. And if you were a magnet and you had a plus and a minus, what would you do in that field? So you're going to be reflected by the red on the plus side, you're going to be reflecting on the blue on the minus side, and the vice versa is that the blue has no effect on the red except to change the color of the blue to red, and vice versa for the negative. So you just have it's all push, it's all imposing, all right, it's all radiation coming off of objects, and you're really just saying the two objects, the electron and the proton, inversely interpret whatever you're shooting. So if I'm shooting blue at the two objects, the electron, okay, reflects it, and the proton absorbs the blue and converts it into red. Okay, so blue goes in, red comes out. If red goes into an electron, blue comes out. Okay, I should just draw the line straight. It comes out the same way, except if the proton is moving, then it comes out a different way, and that's how light is scattered. But anyway, to just understand that it's just about, it's in this case, the electrons are on the outside of atoms, so electrons are really the only thing that matters, because you can't move the protons. They're way too heavy. The whole atom is a big structure. You can't move that without applying a lot of energy. And so what happens is the electrons are easy to move around. That's why there's electricity. And they're on the outside, so that's also convenient. All you're really doing is saying electricity is just how many electrons are there. So if I can't reduce the electron number to 0, okay, so 0 volts doesn't mean 0 electrons. It just means I'm below whatever you've defined the ground is. And the ground can be really any state that you want to call 0. But anyway, we'll get to that later. Probably. Maybe. Possibly.
First, you need to go back to a time before they existed. Back then, in the good old days, if you wanted to move something, you had to push it with your hands. And if you weren't strong enough to push it, you got an animal to pull it.
Okay, so we know the animal's not pulling it. The animal's pushing on the harness. So there's no pull really involved. That pull is a bizarre concept in a sense. We ought to just argue, ought to be able to agree that pull doesn't have an elemental diagram. You can't elementally diagram pulling. Throwing a rock at something and hitting it, you can elementally diagram. Very simple. Pull, throwing something or making something that pulls, well, forget it. You can't do that elementally. You have to make a grabber that pushes. You have to make a harness for the horse to push on if you want the horse to pull. Even if he bites the rope with his teeth and pulls with his teeth, he's really pushing on the rope. So it's always a push. So this is, it's really important semantics, I think, to recognize that pull should always be a doubtable concept. As soon as you're saying something's being pulling, you ought to be looking for where it's being pushed.
Movement required physical pushing or pulling. And with that understanding, there was harmony in the land.
So, this harmony thing, there's never harmony, but whatever, blah, blah, blah.
Unfortunately, soon after, a great mystery arose and threatened to overturn that understanding. I'm speaking, of course, of magnets. Magnets, you see, can push or pull on each other without having to physically interact, flying.
Okay, so without something interact. So obviously the magnets implied that there was, just as light, we don't see light, right? I mean, we see with light, but we don't see light. I don't see the sun's rays. I only see rays that go inside my eye and collapse and push on something inside my eye. I can't watch them do it to something else. I can't see the rays of light. Just like you can't see the laser beam unless you put a bunch of dirt in the environment or molecules that will reflect the light to your eye. So you have to put impediments in the way that will reflect the light to your eye. Otherwise you don't see the light. So it was the same idea. So we knew so lots of people speculated, well, there's a force and it's invisible. We can't see it, but it's actually bouncing between the objects. Not that hard in a sense to understand that, yes, there's something invisible in ether, whatever. And it's changes in that force that are causing the effects.
Completely in the face of everything that we knew and loved. Seeing their great understanding challenged, mankind took the only reasonable approach. They declared magnets to be the work of sorcery. And with that issue settled, they were...
All right, well, so that's sort of true. So the conflict was gravity was sort of, you could do it with different mechanisms because it was only one way. It was just the idea of, depending on how you want to look at it, it was just pulling, right? It's pulling you into the earth. Now, I would argue it's just the absence of a push from the earth that's creating that illusion. The earth is absorbing energy that would have gotten to you. It doesn't get to you, therefore you fall into the lower pressure. But yeah, magnetism creates the opposite notion of the propulsion. And, that is mysterious. And it is hard to explain until you figure out that, in a push universe, the action of attraction and repulsion in magnets. But, as soon as you do this color thing, understanding that it isn't one force, that there's two kinds of charge, plus and minus, there's two kinds of force, plus and minus force, and there's two kinds of interactions, and the two interactions are opposite. Okay, one interaction is a reflection, and one action is an absorption and a change in the identity of that force. And with that simple mechanism, you can explain both attraction and repulsion. You can explain everything electrons and protons do.
Were free to move on with their lives. But, unfortunately for them, It didn't take long for some people to realize that other materials, such as amber or wool, also had the ability to repel nearby objects. And then Newton came along and really screwed things up when he discovered that.
So all of this stuff, okay, they didn't know then, but there was every indication, I suppose they could have guessed at some of it. It's all moving at the same speed. It's all doing the same thing, kind of. And so charge and magnetism and light and all this stuff should have all thought of as one thing, just different manifestations. And certainly when they figured out, that light had a frequency, that there were radio waves and all this stuff, that's sort of a giveaway that the distinction is the frequency, the fact that it's at a frequency. So it's the same force, but this part has a frequency and you can identify it by its frequency. And that's what allows us to extract it out of the environment, is because it has an easy identifier. It has a label, okay, that can be extracted out of a field of noise. It can be seen.
The planets also pull on each other, but this time across massive distances. At this point, people realized that, unless they were going to let the sorcerers win, they'd have to come up with a different explanation. And the explanation they settled on was field theory.
Well, whatever. You're talking 1920 or something, and I don't, field theory doesn't say anything. It certainly doesn't even, before that they had already turned light into this thing. They've created two different fields, electric field and magnetic field, when really the field should be understood as a proton field and an electron field. Yeah, I could go into details, but we'll just let that one slide.
Imagine that you lit a fire inside an enclosed room, and before you passed out from the smoke and carbon monoxide, you'd feel the room get warmer. But how can this be? You aren't standing in the fire. The fire isn't even touching you. So how could it be making you warmer?
Well, it's sort of a bad example. Look, this is nitpicking, but it's sort of a bad example because obviously the radiant heat gets to you much quicker. So at the speed of light, the radiant heat, the infrared radiation is already heating you. And yes, you could wait for the atmospheric effects too, which will be greater, but you're already going to be affected by the speed of light. Information that there's a fire over there.
The answer is that the fire heats up the air immediately next to it. This small pocket of air warms up a larger pocket of air around it, and in this way the pocket of warm air grows until it eventually reaches you, warming you up.
Right, but there's no explanation for exactly what warming up is, but warming up is just this action, right? It's just this idea that you are pushing energy. You're moving electrons and protons, in the case of fire, atoms, and when you move them, they reflect energy to you when they're moving towards you, and they diminish the amount of energy you see when they're moving away from you.
So the fire passes heat to the air, and the air passes heat to you. You might call this a heat field. This same idea is used to explain electric, magnetic, and gravitation.
Probably not the greatest explanation, would be my point. To me, a better explanation would be to show the whole universe is full of ping pong balls, and we're ping pong paddles. And that's what really is happening. So anything in the universe made out of electrons and protons or matter is a paddle, and the ball will bounce off of it. And that way you can understand that you can pressurize this environment. The more paddles you put in, the more space they displace, the faster the balls have to move because they have less space to move in. Okay, so you can add pressure by adding paddles, or you can configure the paddles in such a way that you trap all of the balls between paddles that are close together and create differentials in the pressure in one location to another location. The opportunity for lots of pushing and pulling. But it's not the electrons and the protons have no motion. They have no innate capacity to do anything. They have to actually be pushed by a force. The force moves them. The ping pong balls hitting the paddle move the paddle. To move the paddle into higher pressure, I have to apply a high pressure to push it into pressure. And so you're just measuring the pressure in different locations. And you're just saying that anything in a location where there's more pressure on one side than there is on the other side is going to move towards the lower pressure.
Forces. When two charged particles get close to each other, they don't directly interact. Instead, each particle creates its own disturbance in the surrounding electric.
All right, so let's just understand. They don't create the disturbance. The disturbance is without, I don't create the light reflecting off of me. Okay, I don't become brighter or duller. Okay, the field, okay, interacting with me is what changes because I change my position. So if my position changes to make me further away, my effect on you gets smaller. If the position change makes me move closer, I'm going to push all of the energy from my hand's movement. This section of energy was this much space. But when I moved through it, I condensed it into this much space. I compressed its time. And by compressing it, okay, now I've made a signal where there's more photons in that second, that little, that millisecond. There's more photons in that millisecond heading for you than there are if I go this way. Okay, if I go this way, there's a lot less photons heading for you. And so I'm making a Morse code signal. I'm sending more, sending less, sending more, sending less. Pushing, not pushing. Pushing, not pushing.
Field, and it is this disturbance in the field which acts on and repels the other particle. And because objects are only being acted upon by the nearby field, there is no more action at a distance, preserving the theory that...
Okay, so whatever, there's still, you could call it action at a distance, but it's action at the speed of light through a field that's transmitting photons, that will affect me. They're real things, they're real momentum. And when they hit me with a signal, I'm going to vibrate with the same message this signal contains.
Objects only interact with things immediately next to them. One other thing to know about fields is that they do not update instantaneously. We have again our two electrically charged particles. And let's imagine that one of the particles were to suddenly disappear.
So obviously nothing can do that, so that never happens. But obviously something can do something very fast. Okay, at say the speed of light, it moves up. The amount of time it'll take for the other object to know that it moved away at the speed of light, and now the field is weakening rapidly. So all of that information will take time to get to the other object. So yes, it takes this. The thing transmitting this signal is photons. The energy that makes a photon. The same energy that makes a photon makes gravity, makes magnetism, makes charge. It's all made out of the same stuff moving the speed of light. All you're saying is, am I producing more of that stuff or less of that stuff? And the stuff would be relevant to whether you're producing stuff that affects electrons, pushes them, or stuff that pushes protons. We just happen to live in a universe where the protons are on the inside and electrons are on the outside. And the electrons are the things that we're going to be able to see or change easily.
Scenario, the second particle would still momentarily feel a force on it. Changes in the electric field travel through space at a finite speed, and so the force on the second particle will only disappear once the local field updates to reflect the
Alright, so it's not a field updating, it's actually little clowns on tricycles driving to the location. So if you just understood it as light, you understand that if the sun instantaneously poofed away, there's still 8 minutes of sunlight that's still going to get here. Because they're real photons, they're real things in the universe, and they're moving at a speed, and you didn't change, you can't undo their production. You just got to wait for them to finish the 8 minutes, and then that'll be it. Then everything goes dark. Now, I think that would have been a simpler analogy, is just to say, what if the sun turned off, didn't create any more photons, and we'd still have 8 minutes of sunlight.
First particle. Updates to the field move at a speed of 300 million meters per second, and this speed is often referred to as c, or as the speed of light.
Right, and this would be a good point to argue in physics that shouldn't this be changed to the speed of force? Because all the forces are moving this speed, so it is not a light-specific thing. It's fundamental to whatever this invisible elemental stuff is that makes magnets work, it makes charge work, it makes gravity work, also makes light work. It's all the same stuff, And so it's really the speed of force. And so this is a little semantics thing, but it's another one of these mistakes of our vernacular, the old jargon, okay, that doesn't really tell the right story, because this isn't really about light. It's about force. And it's about light is just a kind, a specific arrangement of force. It's force wearing a certain hat. It's force at a certain configuration. It's a Morse code signal of force. So it's all the same stuff. It's just that you've given it a property that it doesn't, the other force doesn't have. And when it has that property, then we can call it light. But its elemental function is still, it's just force. And forces don't interact with forces, which can be demonstrated that magnetic fields don't interact with the other field. The fields have to get to a piece of matter to have an effect. Gravity has to get to another material object to have an effect. You can't bounce gravity off of gravity. You can't bounce magnetism off of magnetism. You can't bounce charge off a charge. You have to go to a charged object before the force has any effect. It has to find a piece of matter to affect, because it can't bang into another force. And so that sort of is demonstrated by the laser beams not being able to interact, and there's no lightsaber bullshit, and there's no physical interaction between force against force. It always has to go through the conduit of moving a piece of matter. The matter moves, that changes the configuration of the force. Changing the configuration of the force causes matter to move. Something like that. Alright, probably should just do a little update here. So what needs to be understood first off is there's no pull. It's a push universe. And there's only two things in the universe, matter and forces. So you have the objects like electrons, and then you have a field of something smaller that has momentum, and it moves the speed of light. And if you move it at a specific frequency, you call it light. Okay, if it's not at a specific frequency, if it's, sloppily configured and it has a wide polarization, it's going all over the place, blah, 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 then it's still momentum. It's just not going to be something you can detect as a pattern, having the pattern. So it won't be called light, but it has the same effect as light, as if that's a real force. Alright, well anyway, so all you have is the matter bits and the force bits. So all the little force bits are in the universe already, all moving around. You're getting hit by them constantly right now, cell phones, all kinds of stuff. Stuff that reflects off the moon, it comes back to you and hits you. I mean, it's stuff coming from all over the place, little bits of this energy with frequency, not with frequency. And the idea is that you have an equilibrium with that stuff. That is, that stuff, okay, all hits you, and then you reflect it eventually back. And the question is, the you, okay, as a collection of atoms, behaves a little bit different than the electron and the proton. The electron and proton have to be at equilibrium, in a sense, okay, except when they're moving in a direction. So what's the choice when the object hits? What really happens? Okay, so here's an electron, and I'm going to now apply a force, and then I'm going to have, just imagine a million little bits hitting it, but I'm going to change the scenario so there's one more bit, just one, okay, one more, coming from this direction. Then it's coming from all these other directions. Well, how does the electron respond to that one bit, that one extra bit hitting it? And that's the question. So the idea would be is that the force is going to be reflected eventually. But that's it, eventually. But while the electron moves, it's absorbed a force to do it. So the idea would be is this one extra hits and sticks, and it's now going to move the electron in this direction. So the electron will now move much slower than the speed of light. Okay, less than, see. A lot less than, okay, a lot less than the speed of light. So the electron is now moving because it absorbed a piece of extra force, pressure, from one direction. And there's no responding pressure from the other side to get rid of it. So yes, there's still a bunch of force hitting from this direction, but there's an equal amount coming from this direction, and so they all are reflecting. Okay, and the only one that made a difference is this one extra, okay, because it sticks. So that's the idea, is that it sticks until a counter force comes from the other direction and hits, and then they both reflect, and now this goes back to being neutral, not moving. So it only moves in the direction of a field imbalance. And it doesn't matter when it was in the field imbalance, It just means that there's overall been a field imbalance in its history somewhere, and that will account for its motion. Is that imbalance is sort of perpetual, in that it isn't undone until you actually do send one in this way. So all you do is stop it from moving, and then it starts moving again because it still has that extra, okay, that in the field, so to speak, and that extra is on this side of the universe, and it can come back and get you. Alright, so I don't want to get into that complexity of how you create a mechanism against drag. But the simple point is that's all that's really happening. So there's no pull. There's just an absence of push. So if I move my hand away from you, less energy gets to you, okay? And if somebody isn't moving their hand away from you on the other side of you, you're going to move into that change in the field I've created by moving my reflections away from you and causing you to get hit by less energy from my location than the other side of the universe. And that's all that electrons are doing. They're just moving into pressure changes. They move from high pressure into low pressure. That's all that happens, and that's what's happening with electricity. So just understanding that it's a simple mechanical universe made out of mechanical things. There's just throwing, there's just reflecting, and there's nothing else. Everything's at this equilibrium thing, and well, I don't want to get into the gravity argument, but there's a subtle consumption because of this rule. The electron moves a little slower than the speed of light, which means the force actually loses momentum while it's pushing elemental matter. So when the elemental matter is moving, it's moving slower than the speed of light, which means the force that's pushing it isn't moving at the speed of light anymore, and therefore it's lost some of its momentum. That's what's creating gravity. All right. So you really can't do one subject without doing all the subjects, and then it ends up being a 5-hour video. But I can't do much about that. Really can't. I mean, but it's really important, I think, to understanding the subject that all there is push. There's no elemental construction of a pull. Push is easy. Push just means you have a universe full of little bits of energy moving the speed of light, and you just reflect them. And the essence of the function is just the fact that you have electrons and protons, material bits, that don't have motion, and they are going to be moved by the force, and depending on where they're positioned, they're going to reflect the force differently and create a different environment for the other stuff in the field. So every time I move my location, I change what everything in the universe sees, technically. I mean, obviously it doesn't see me, okay, but it sees the energy from me. And there is just a fact that if I change my location, I change how it gets hit. Pluto, okay, is getting hit with a different amount of energy because I moved my hand from here to here. Now, it's insanely subtle, and it's a tiny amount. If you try to add it up, it would take you 10,000 years to detect the tiny bit of movement or whatever. You know, it's tiny, tiny, tiny. But it's a fact that everything else in the universe is affected by everything else in the universe. Its location any change in its location changes how it's going to be pushed. That is a key understanding, I think. What do I want to do here? Oh yeah, I want to play the video. So we put the video back, we get rid of that, and then we continue playing this.
Once scientists agreed upon the existence of fields, they next needed a way to draw them. They eventually settled on the following convention. Let's say there is a positively charged particle. To draw the electric field around it, imagine that this particle is surrounded by more positively charged particles. We then draw the repulsion force that each particle would feel. If you then...
So I think this would be easier if just, again, Maxwell didn't bother with this. So Maxwell just drew this charge as a radiating body. And then the downside was he drew the opposite charge as a consuming body. Okay, but no, they're both radiating. They're just radiating something opposite to each other. And that way you can understand why there's push and pull. It's because you can understand why there's an absence of push. It's because one is changing the force, okay, to something inert to the other object. So they can only be affected by a force that comes off of the same. An electron can only be affected by an electron because the proton is going to convert all the energy coming out of it into proton force, which the electron can't see. It can't be affected by it, can't be pushed by it. And every bit of proton force that does go into the electron comes out as electron force. So the proton is always red and the electron is always blue, you could argue. That's all they radiate. So no matter what color goes in, so red goes in, blue comes out. And blue reflects. So all the reflections are blue, all the conversions are blue, therefore the object ends up just radiating red and blue. So in the, so if you understood it that way as a color diagram. See, they're using color, but they're messing it up because they're not showing it radiating the color. So if you showed this radiating red, and then showed the blue as radiating blue, and then understood that blue is inert to red, and red is inert to blue, and that only red can see red, and only blue can see blue, then you'd really see how charge works.
Remove the surrounding particles, you were left with a ring of outwardly pointing arrows, which is how we represent the electric field. If we wanted to draw the electric field around a negative particle, we use the same procedure. And since positive particles are attracted to negative particles, the arrows that we draw all face.
So again, this is so arbitrary because you're using positive. If I just changed it to a negative particle, then all of a sudden the arrows are going in the outward direction. You see, it's arbitrary. It doesn't get elemental. This isn't an elemental drawing. It really doesn't get to an elemental function. These are just two objects that reflect. Light comes in, they create an equilibrium. Light energy comes in, they produce the same energy out, and the trick is that the blue one converts red to blue, and the red one converts red to blue. Blue to red. And so they radiate two different colors. And you can have places where it looks like purple, and those would be the neutral places, and every other place is going to look more blue, more blue-purple, or red-violet kind of color. And that decides the pressure at that location.
Inwards. These sets of arrows, which show the force on any nearby positively charged particle, form our basic building blocks of drawing electric fields. Note that since positive particles are used to generate the arrows, a negative particle will be pushed.
Right, exactly. So since it's completely arbitrary, you get the sense that one object's pushing and one object's pulling. But it's really not. They're both pushing. Okay? It's just that they're pushing something fundamentally different to each other.
The opposite direction of that shown by the electric field. Now let's say we want to represent the electric field created by multiple particles. Performing the same procedure as before, we see that the test particle experiences a pair of forces, and if we had...
Right, so that's all we really have to do is to say, okay, we know electricity is about electrons, and why is it about electrons? Because electrons are small. The nucleus is, tiny and dense and, in the middle, and it's not easily moved. You have to move all the electrons and all the stuff in the nucleus to move the nucleus. It's a big, giant total mass, where the electrons on the outside are easy to move. So you can change how the atom looks by messing with the electrons. So all you're really saying is if I want to change the pressure in a system, I just start adding more positives or adding more negatives, and they're going to have to adapt to the pressure. So if I add one more magnet to the magnet pool, all the magnets get more pressurized. That is, the pressure between them gets stronger, and at any time I can just release their energy, and I'll be releasing more energy because I pushed more force in by pushing more objects in. The more objects, the faster the BBs bounce.
These two forces together, we
the
get...
more impacts they have with objects, the more momentum they transfer.
The net force to the right. Performing this exercise at every possible location gives us the overall electric field.
Alright, so these are field lines. So instead of lines of force, the original lines of force are all coming out straight and doing straight things. There's no curved lines of force. Lines of force are all straight. These are arbitrary places where the combination of the two fields are equal. But they're not real locations, they're not real places, they're not real things. There's nothing traveling this curved line. This curved line is just when you add up how much blue is getting here and how much red is getting here, it's clearly very red. Okay? That's all this curve is being created by. But the force, the field lines, lines of force are straight, dead straight. And everything that happens at those points, any combination of the field lines is just arbitrarily showing you where now the new place of equality is, because now you have more blue in the field and it's bending, so to speak, the line, but there is no line. There's still just radiant force, and you're just saying how polluted is it by the blue light. You have red light shooting. How much pollution from the blue light do you have?
We could instead analyze a pair of positive particles. With this setup, we see that in most locations, the two forces acting on the test particle add together, resulting in a stronger force. However, in the middle of the field, the forces on the test particle cancel out, resulting in zero net force. So, when two positive particles are brought together, the electric field around the particles grows stronger, which is shown by an increase in the number of arrows.
Alright, so how to say this? Obviously you have more stronger, it's just not the right way to say it. Let me think of a way to describe this. You can't change the number of lines of force, so that can't change. All you're doing is pointing out that at any one of these locations, because of the inverse square law, I can get closer to this object and further from this object, but it's still the same amount of red no matter where I go in this entire field. It's the same amount of red is going to hit me, because I'm either going to be hit by more from one object or more from the other object as the other one is less. So these are just points where the color red is the same richness. Okay, it's just as red. Okay, I can't make it any other redness. Okay, because I'm getting hit by the same amount of red. Oh, Jesus, that's the other. And then this is where it gets polluted by reality out here. The rest of the universe is influencing. I'm still not even like that. Don't even like that. You're just saying this is where it's reflecting. This is reflecting. This is reflecting. They're two ping pong paddles. There's energy bouncing back and forth, but their fields are round, so they can move this way. Any change in their position would force them to move in a direction away from each other, because they're going to be affected by energy in more. The energy going straight across is irrelevant to an object placed here, right? An object placed here can't see this energy going back and forth. All it's seeing is this ray and this ray. So it's getting pushed from this side and getting pushed from this side, and it goes this way. That doesn't, I mean, the lines of force were still this way. The fact that the thing leaves this way doesn't change. These are the lines of force. This is what was sent to it. This is the light it got hit by. And it just happened to move it this way, and the matter did the math and figured out that means this way. That probably was the simple way to say it. The matter does the math. This is what the matter does. These lines are not the force. They're what matter moves, the direction the matter moves. This is a diagram of how the matter moves a charge, a positive charge. This is where a positive charge will move, but it is not what the force is doing. It's not illustrating the force. It's illustrating the direction a charge takes. And if I put a negative charge in here, then it would be an opposite direction.
Meanwhile, the field between the particles gets weaker, which is represented by a lack of arrows. Now at this point, I bet a lot of you are thinking something.
Okay, so there is no lack of arrows. So it's just that they're canceling arrows. So they can't have an effect because they exactly cancel each other. So they obviously can't change anything's direction. But there's still lines of force there. That just that it won't, an electron won't be compelled to move. It won't. There's no math to do. The math is a perfect cancellation, so there's no math product, so there's no motion. So because they're representing where the matter moves, there's no movement there, so there's not going to be any motion. Well, this video is getting a little bit long, so I'll probably end around an hour's worth for part 1. I only got through 7 minutes. Not very good, but they're important concepts. Okay, and the idea of, the arbitrariness of so much of the elemental fill-ins, the gaps where they've just filled in with some notion that the charge, the positive charge is sucking and the negative charge is blowing, and no. that's not a good enough explanation. So there's no, they don't really talk about any elemental function that propels electrons and protons, that motivates them to move. It's all some sort of bent geodesic blah. Okay, so there's no mechanism. So they say the real thing or the real explanation are electricity explained, but they're really not explaining it, in my opinion.
Something like, so big whoop. So field theory solves the force at a distance problem. Is there anything else it's good for? Well, I'm glad you asked. Imagine that these two magnets are a pair of charged particles which are pushing against each other.
So this is the good analogy. I mean, and all you really have to do is undo what Maxwell said, which is there's no electrical monopoles. And just understand that, no, there are. The electron and the proton are the monopoles, okay, of electricity and magnetism. They are the monopoles. They are the monopoles of charge. They are that. So thinking of an electron as a negative magnet and a north magnet, then you're saying, okay, what happens if I put two north magnets into relation to each other? Well, they pressurize
each other. As I bring the left particle towards the center, I have to overcome the repulsive force.
Right, and so what have you done? You've created pressure, which is essentially analogous to voltage. You've created a voltage, by forcing a proximity, a closeness. So the faster an electron moves towards a field of electrons, the higher the voltage, because the closer it's going to get before the other element can react and move. It takes time for the electron to move because it doesn't move the speed of light. It can't move as fast as the information is getting to it. Therefore, it compiles more and more pressure. That's the voltage. Low pressure means it's going to move less aggressively. High pressure means it moves more aggressively.
And I'm therefore adding potential energy to the particle. When I release the particle, it converts that potential energy into kinetic energy.
So, playing with this potential and kinetic again, when it's all kinetic energy in the universe, there's no potential energy, and all you're really saying is, I've trapped it. You've trapped it by holding it there. You have two fingers pressing on it, forcing the high friction, okay, and that's all you're doing. You're creating so much friction that it can't overcome the friction. You're forcing the two things together. And there's just a point where you're releasing what you've stored, and what you've stored is energy bouncing back and forth, reflections, heat. Essentially, the heat of the one electron, the heat of the electron, and the heat is bouncing back and forth, and there's lots of interaction. So if I have two ping pong paddles and they're this far apart, and I move them this close, and there's just one ball bouncing between them, well, I've doubled the energy, because the ball hits twice as many times now and transfers its energy twice as many times.
Now, what if I tried that experiment again, but this time I released the right particle? As you may guess, it also flies away, onto the floor, and probably down an air vent. But how is that possible? I put potential energy into the left particle, and yet the right particle was the one to gain the kinetic energy.
Well, see, because there is no potential energy, there's just stored energy. You stored energy in a vessel, and you create two doors you could open. So yeah, whatever door you open is where the pressure will go. So that's the more rational analogy, in my opinion, is just to recognize that you've stored something between them. It's an active kinetic force you've stored, you've trapped, and you've just now saying, I'm going to let it loose. I'm going to let the high pressure I've created loose to the universe that has lower pressure. Now, if I did that inside of a field of magnets, pushing the two magnets together, well, then they wouldn't be releasing the pressure, but you have as much pressure on the outside as you'd have on the inside.
Was the energy somehow transferred between the two particles? Did the right particle steal the energy from the left one? To answer this question, we'll run the same experiment, but with some marbles and a spring instead of
So it's, it's technically not the same experiment, but whatever. What's the point to make? Yeah, so I'm just saying the analogy is wrong. What you're doing is storing pressure. You're storing a voltage. So you compress the spring, you're compressing, you're changing the magnetic configuration in the spring, and it is created traps, pressure circumstances that obligate it to bounce away from that pressure.
magnets. And with this setup, we see that
I mean, it's sort of obvious, when you're compressing the spring, what are you doing? You're contracting it, you're forcing the electrons closer to each other, blah, 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 blah.
potential energy is being stored in the spring, not in the marbles. And when I let go of either marble, the spring is transferring its potential energy into the marble as kinetic energy. In a similar fashion, when I bring...
So that brings up a question, though, is what's the total amount of energy the spring can deliver? And is it possible that it can deliver extra, twice as much energy to one side as the other side? Is there one amount of energy you're going to see? And the trick is that when you're holding the one object and compressing the spring, that pressure still exists in the ground. It's going into the ground. It's still being applied to the other side. And so the one side of the spring can only release a certain amount of pressure, and it can't release more pressure.
the two particles together, the electric field that they generate acts like an invisible spring, storing potential energy.
So what it acts as is a ping pong paddle trapping a ball. And so there's a ball between the two ping pong paddles, and as I bring them closer together, you can understand it's hitting here, it's hitting here, it's hitting here. It's moving really, really fast now because you brought it together. So it's hitting the surface more times per second.
The stronger that the field gets, the more energy that is stored.
Yeah, the closer you get, the more impacts, the more pressure.
And when I release either particle, the field transfers the potential energy into the particle as kinetic energy.
All right, so again, there's no such thing as potential energy. There's just energy. There's pressure in the universe. You can collect it in locations. You can trap it. And then you can have less pressure. You can take pressure from one place, put it in another place. It means if you've created more pressure, it just means you've moved more electrons or more something to a location. You're confining the more pressure, and there has to be less pressure somewhere else because now you've made more free space somewhere else.
Therefore, field theory solves no...
You can't change the total amount of space. You can only change how the space is distributed.
Not only the force at a distance problem, but also the energy transfer problem.
All right, so these aren't really great answers, in my opinion. They're not perfect analogies. It's not the real story. It's better than Veritasium's story, okay, but it's not the real story. And this really doesn't get to the Veritasium subject yet anyway. But just as he felt the need to premise his argument with these explanations, I feel the same need to premise my rejection of his theory, okay, with the same premises that now you're thinking about it wrong. If there is no magical fields created, there is a field already in the universe, and all you're doing is affecting that field that already exists. You don't make electric fields, you don't make magnetic fields. All you do is change the field that already exists. And by changing it, okay, by making changes to it, by changing the dot dot into a dash dot, that kind of thing, you change how the object will interact with that field that you've changed. Alright, so that's probably enough for a part one. And we'll do all of them. I'll probably put the rest of them on the website. So this one I'll put on Google, YouTube, the censoring bastards. And the rest of the parts will be on the website. Alright, so until the next time and such, this has been a draftphysics.com video presentation. Be interested if I can get him on the subject of kinetic energy versus momentum, and acknowledge that the two theories are not compatible at all. That would be interesting. Okay, anyway, so till the next time and such.